Hi everybody, Mrs. Bolin here. This week we're taking a look at standard 32, surface area and volume of cones. And we are going to have to come up with two different formulas for surface area and for volume. When we take a look at our cone here, it looks a lot like the cylinders that we worked with, where our base is a circle. However, you don't have two bases that are circles, or you don't have a base that's a circle on the bottom and on the top. So one way you can think of a cone is like an ice cream cone, where you've got your base, which is a circle, and this circle is being stacked all the way through the figure, but every time you stack it, the circle gets smaller and smaller and smaller and smaller, and then comes to a point at the very top. So the fact that we only have one base, or you could say you have a bottom or a top to it, that's the first thing that changes with our surface area formula. Thinking of prisms, we're used to doing our height times our perimeter plus 2 base. There's no longer going to be plus 2 base at the end of our formula. It's just going to be plus b at the end. So leave a space, but we're only going to have one base, so plus b. Again, our base is a circle. So you're finding area, the flat area here of this circle. And we learned that area of a circle, you could think back to the cylinders or think back to when we worked with circles in previous trimesters. Your base is going to be pi times your radius squared. So we found the first piece here to our formula. Base is the area of a circle. So it's pi times radius squared, and you will want to use the pi button. All right, so surface area, we're trying to wrap this cone. We took care of the flat bottom base, but now we need to wrap around the cone in a circle, but it's also slanted. So that's the unique part, and that's the tricky part to this formula. Because we're working with a circle, we learned last trimester, whenever you're working with circles, we deal with pi. So that's the first part. Again, pi is just a number, 3.14, etc. And then in order to impact the size of the circle, we would look at our radius. So right here would be your radius. It goes from the center of the circle to the edge. So we will do pi times our radius. So again, we're using our radius here. Pi times our radius, that's the center to the edge that we'll be plugging in. And then the last thing we have to account for is the fact that this would be slanted, right? If you're trying to wrap it. So this is something called slant height, and I just drew a cursive L, and we can label it, this cursive L is called slant height. So that is something new, but it's called just what it is. It's the slanted height, right? You can tell it's slanted or it's at a diagonal. So your slant height, cursive L, is the slanted piece. So here are all the pieces to our surface area formula. We'll do pi times our radius times the slant height, and then whatever we get when we multiply these three numbers together, we will add our base, and then we have our surface area. The volume formula is actually much easier, and we're used to just doing base times height to our volume. The only issue with that is if we're trying to fill this cone, we can't just do base times our height. And you can see right here would be our true height. I'll label it H star, just like I did with the prisms. This is our true height. So you could note that we have base times height, but we have to account for the fact that this circle is getting smaller and smaller as it stacks through the figure. So in order to account for that, we put a 1/3 out front. So we're doing 1/3 times our base, which again is the area of the circle, times our height. And this is our true height. Think of it if you were to measure it from the base all the way to the very top. And notice I'm using H star just like I did with my, my prisms from last week. All right, so these are our formulas. I would make sure you have these written down, and let's jump into example A. So in example A, we have our first cone. And it starts by asking what is missing in the picture, our height or our slant height. And you have to decide which is missing, height or slant height. And the way you decide that is by looking at the triangle here. can see we have a triangle. I'll do it in a different color here to emphasize it. And noticing what is labeled. So this 16 meters here is going from the base to the very tip point, straight up and down, as if you were to measure its true height. So that's our true height, H star. The 8 meters here, that's on our base, going from the center to the edge. So that's our radius. And then what we're missing, if you want to draw an arrow to the slanted side of the figure, we're missing our slant height. So I'm going to write, again, cursive L for slant height. Slant height equals, and we don't know what that measurement is. So in this figure, we're missing our slant height. You can tell because there's no number measurement labeling the slanted side to my figure. So that's what I'm going to have to find my slant height. And every one of these cone problems, you will be given either height or slant height, and you will have to find the other one. The way you find the missing height or slant height is by looking at this right triangle that I kind of emphasized here in pink. And we're going to use something called the Pythagorean theorem. Hopefully that sounds very familiar to you. We actually have 3 standards last trimester working with it. And what Pythagorean theorem says is a squared plus b squared equals c squared. And I'm talking about this right triangle. The A and the B are your legs, or the 2 sides that form the right angle. And the C is your hypotenuse, or in this case, it's our slant height. So you can use a squared plus b squared equals c squared, and consider c is always your slant height, the hypotenuse, or if you want to use different letters, you may. But I'm going to have to do Pythagorean theorem to find my slant height. So my 2 legs, A and B, and it doesn't matter which leg is A, which leg is B, my 2 legs are 8 and 16. So I'm doing 8 squared plus 16 squared equals my c squared, or you could say my slant height squared. In your calculator, you can do this, 8 squared plus 16 squared, or that's really 8 times 8 plus 16 times 16, and I get 320 when I do that. So I get 320 equals c squared. But I don't want my hypotenuse squared or my slant height squared. I just want c, my hypotenuse, by itself. So I get my final answer by taking the square root of each side. So in your calculator, you're using the square root button to take the square root of 320. And I'll round to 2 decimal places. I'm getting 17.89. So here is my slant height measurement, 17.89. So now I found all of the pieces here on the figure, so you can consider that like your scratch work. This right here, all this writing that I did in pink was just the Pythagorean theorem in order to find the missing height or slant height. So now that I did Pythagorean theorem, I know my slant height. There's one other piece of scratch work I have to do, just like we've been doing with the prisms and with the cylinders, is you need to find your base. So scratch work for big B, we know that our formula for big B up here is pi times radius squared because we're finding the area of the circle. So I'm doing pi times my radius here is 8 squared. And again, I'm pulling this radius measurement from the figure. My radius is 8. So I'm doing pi times 8 squared in my calculator, which gives me 201.06. So there's my base measurement. And so now I did all my scratch work. I have, because if you look at your formulas up here, I have all the different parts, right? I know my radius, I know my slant height, I know my base, and I know my true height. So now we can plug it into our surface area and volume formulas. So surface area equals, and I'm just looking at the formulas up above. So my formulas tell me I do pi times my radius, which we said is 8. Again, that's coming from the figure, my radius of 8. Times my slant height, which we had to do Pythagorean theorem to find. So my slant height is 17.89. Coming from the figure over here, slant height, 17.89. Plus my base, which we found to be 201.06. Coming from up here, my big B, right, 201.06. So there's my formula. I would just be careful putting this in your calculator. I would probably type pi button times 8 times 17.89. I would get an answer, and then I would add the 201.06 to it. And then for surface area, when I do all of that, I get 650.68, and that would be square meters. So there's my first answer. And then volume, the easier formula. We're so used to just doing base times height really quick in our calculator. Don't forget the 1/3 out front. So the best way to handle this fraction 1/3 in your calculator is to put parentheses around it. So do parentheses, 1 divided by 3, close your parentheses. So 1/3 times my base, which is 201.06, times my height, and that's my true height of the pyramid. So that's my H star over here, which is 16. So times 16. And then because these are just 3 numbers multiplied, you can do all this in one step. So do 1 divided by 3 times our base times our height here. And then for volume, we get 1072.32 cubic meters. When you get answers that are like 1,000, you should not be putting a comma in your answer when you type it onto your Schoology practice quiz. No comma belongs here. All right, at this time, go ahead, pause the video and try number 1 and see what you come up with. All right, here are my surface area and volume answers for you try 1. In this problem, just like the example, you had to do Pythagorean theorem in order to find your slant height. But then once you knew your slant height and you found your base formula, you had everything you needed to plug in for surface area and volume. Let's look at example B. And the only thing that's different about example B is actually this piece right here. When it says 22 meters, that's really our diameter. So I would make a note, if the diameter cutting all the way across the circle is 22, then our radius is half of that. Our radius has to be 11. What is missing in the picture? Well, we know our radius is 11, or like just that little piece would be 11. And then the 22 right here is labeling our height. So that's our H star. We need to find on the outside here what our slant height is. So again, we're missing slant height. If it's helpful, you can emphasize the right triangle that you're looking at. Right angle, so you've got 2 legs. So your legs here, your radius right here would be 11. 11 and your height is 22. So I'm doing 11 squared plus 22 squared equals c squared, or you could say your slant height squared. When I do 11 squared plus 22 squared, I get 605 equals c squared. In order to undo my c squared for my hypotenuse squared, I take the square root of both sides, and I get c equals 24.60, which means up here I can label my slant height 24.60. So I have everything on my figure labeled now by doing Pythagorean theorem in order to find my slant height. Let's find my big B. So that's some scratch work. So we're doing pi times our radius, which is 11 squared. And again, my radius is really just cutting halfway across the figure, right? So radius of 11, which gives me 380.13. So now we have everything we need to plug into our surface area and volume formulas. So for surface area, doing pi times my radius of 11 times my slant height, which we had to do Pythagorean theorem to find. So our slant height is 24.60. Again, that piece is coming here from the figure, 24.60, plus our base. Our base we found to be 380.13. And then when we type all of this into our calculator, for surface area, we get 1,230.24 square meters. And then our volume is our easier formula. We do 1/3 times our base, which is 380.13, times our height, and this is our true height of the pyramid. So we labeled that right here, the 22 meters, our H star. So we're doing times 22. We just have 3 numbers being multiplied here, so you can plug those into your calculator. And when we do that, I get 2,787.62 cubic meters. Let's see, if instead of typing in parentheses 1 divided by 3, closing your parentheses to handle this 1/3, another way that you could do this volume is multiply your base times your height, and whatever number you get, divide it by 3. So that would be another way, but sometimes I find that when students do base times height, they forget to do that last step of divide by 3. And if you don't divide by 3, obviously your answer is going to be much larger. So just be very careful of that. You've got you try 2 to do, so go ahead and pause the video. All right, on you try 2, I know that my diameter was 18, so I took half of that to get my radius. I was missing my slant height, so I had to do Pythagorean theorem in order to find my slant height measurement. After doing my base scratch work, I could plug everything in to get my surface area and volume answers. All right, let's move on to example C. And on example C, we are asked what is missing in the picture. So we probably need to start doing some labeling. The 10 yards is our radius. And this 22.4 is our slant height. That's on the diagonal. So that means we must be missing our true height. And in this figure, the issue is that when we're missing our true height, we actually need to draw it in. So notice I drew in the height in order to form that right triangle. So here's what we're missing. We're missing my height. So I'll put height equals, H star equals, and that's what we need to find. We're going to have to do Pythagorean theorem in order to find that height. So now my Pythagorean theorem looks just a little bit different. My legs are still A and B, and my hypotenuse is still C, but I'm missing one of my legs, right? So this H star, my true height here, we could just call that A. So I'm doing A squared plus my other leg squared, which is 10. So A squared plus 10 squared equals my hypotenuse, which we know is 22.4 squared. So Pythagorean theorem looks just a little bit different because now we're missing a leg. So A squared plus 10 squared is 100. And 22.4 squared, is 501.76. I'm trying to get A, my height, my leg by itself. So I need to move this 100 to the other side, and I do that by subtracting 100 from both sides. So then on the left, I'm left with A squared equals, when I subtract 100, now I have 401.76. And then my last step, I don't want my leg squared, or I don't want A squared, so I have to use the square root button in my calculator. And when I take the square root of 401.76, I get 20.04. So now I know my height up here is 20.04. So I have everything labeled on my figure. Let's do our base, which is pi times our radius of 10 squared. 10 is my radius. Pi times 10 squared. When I do that, I get 314.16. So now I have everything I need. I've got my cone completely labeled. I did Pythagorean theorem to find my missing height. I did my scratch work for my base. Now we can plug it into the surface area formula. So pi times my radius of 10 times my slant height, which the problem gave us, 22.4, plus my base, and I'm running out of room here, plus 314.16 from my scratch work for finding base. So then I can do that whole piece in my calculator. And when I do that for surface area, I get 1,017.88 square yards. For my volume, I do 1/3 base times height. My base is 314.16 times my height, which is my true height. We had to find it. That was the 20.04. Then when I do that piece in my calculator for my volume, I get 2,098.59 cubic yards. And at this time, you can pause the video and try number 3. See how you did. Here's what I came up with for you. Try number 3. I had to do just like example C, where I was missing my height. So I had to do Pythagorean theorem to find a missing leg for my height. I plugged into my base formula to find my base. And then here are my surface area and volume measurements that I came up with. So we have one last example to do. Let's see, the back side, example D, and very last one to do, what is missing in the picture. So let's label the 17.9, that would be our slant height. The 16 feet is actually our diameter, so you can make a note that if the diameter is 16, my radius has to be half of that, or my radius has to be 8. And then from looking at the figure, I'm missing my height. I have to draw in my own triangle. So you can draw in your triangle to emphasize the right triangle. And that's what I have to find. Right here, I need to find my height of the cone. So that means we have to do Pythagorean theorem. So I have one leg, I'm missing a leg, and I have my hypotenuse. So for the leg that I'm missing, my H star, I'll just call that A. So I can do A squared plus my other leg squared, which is 8 squared, equals my hypotenuse squared, so 17.9 squared. So then I'll have A squared plus 8 squared is 64, 17.9 squared is 320.41. Trying to get A by itself, so I need to move this positive 64 to the other side. So I do that by subtracting 64. And then I'm left with A squared on the left. And on the right, I'm left with 256.41. Last step, take the square root of both sides. And I get A equals, let's say 16.01. Which means my height that I had to find is 16.01. So we had to do all of this work for Pythagorean theorem to find our missing height. Again, that's the true height if you were to measure from the base of your cone all the way to the very top point. Now let's go ahead and do our base formula. So base equals pi times my radius of 8 squared. Be very careful, make sure you're using your radius of 8, not the diameter of 16. When I do that, I get 201.06 for my base. So I have my figure completely labeled. I did my scratch work for base. Now we can plug it into surface area and volume. So surface area for my cone equals pi times my radius of 8. Whoops. Times my slant height, which was given to us, the 17.9. plus my base, which is 201.06. When I do all of that utilizing my calculator, I get 650.94 square feet. For my volume, I do 1/3 times my base of 201.06 times my height, and our height is what we had to find. So my height is over here, the 16.1. So I'm doing times 16.01. And then for my last volume measurement, I get 1,072.99 cubic feet. So there was our last example. And at this time, actually, I would like for you to work on U-tries 4 through 10. So these are all different problems kind of jumbled up. So give them a try and click play when you're ready to see the answers. All right, here's all of my work written out for U-try number 4. And you can see my final surface area and volume measurements. And then for the rest of the problems, they were kind of all mixed together. So for these ones, what I did is I just put final answers here. So for 5, 6, and 7, you can see I didn't show all of my work for Pythagorean theorem to find your missing height or slant height, and I didn't show all my work for finding my big B, but I am indicating to you what was missing from the figure, how you should label your figure, what your big B is, and then what your final answers for surface area and volume are. So make sure you check 5, 6, and 7. And then here are answers for 8, 9, and 10.